Okay, can we take a few minutes and go over these problems that we did, and then we'll talk a little bit more about multiplication and division of fractions. That's okay. I just wanted you to do the first 4 questions, so we'll talk more about the others before you move on. If you've moved ahead, that's good too, but...
Is there another?
Oh, yes. Okay, so the lifespan of a lynx is about 3/4 the lifespan of a cougar. The average lifespan of a cougar is 20 years. What is the lifespan of a lynx? How did you do that? Are you boys making cougar jokes over there? How did you do this one, Dennis? Megan will show us?
I just did a number line.
A number line?
0, 0 to 20.
Okay.
Counting by 5, and then this one is kind of easy. You know that 84 to 20 is even, so it's just you jump 3 times.
Okay.
5.
So you have a number line. You can look at 3 out of 4 parts. So 20 years is the cougar, 15 years is the lynx.
Yeah. Are we making the assumption that the child has like made the association that 4 goes into 20, or that there's 5 parts?
Well,
4 parts of 5.
by the time we do division of fractions, we're in grade 8. So surely to God, we know that 4 times 5 is 20.
So
But I
for
guess
it
that
to make
connection-
sense to the student, the way that she did that with, you take 20 and divide it into 4 parts, because that's the bottom part of that.
Yeah.
And then you jump 3 times. Okay.
Another way that you could do it is to look at an area model.
Oh, I did that.
Did you do it that way?
I did that way, yeah.
Okay.
I split it into fourths.
You broke it into fourths.
And then
Okay.
and I split that into
20ths.
Yeah.
Another way would be to model it with 2 color counters, which I forgot to put out. But if you had red and yellow counters, you could put out 20 red counters and then change 3/4 of them to yellow, and you would show it that way. Okay. But because kids should have, as Sarah asked, they should have a good sense of kind of the parts of 20. Like this one is a pretty straightforward. You can reason it out, right? Because they know, well, 20, if I think about it in quarters, each quarter is 5 years, right? So 3/4 of that is 15 years. Let's come back to 2. Let's go to 3. Okay. So question 3, it says how many buckets of water would you need to water 9 plants if each plant needed 1/2 of a bucket of water? So what did you do for that?
9 plants.
Okay, 9 plants.
A symbolization for 9 plants.
Okay, I'm going to do it. I know, I'm trying to cheat. Make them look pretty, but it's okay, there's my 9 plants. And each plant gets 1/2 a bucket of water. So together, 2 plants would get a whole bucket of water. So how many buckets of water do I need? 4.5. Okay, so this is involving a whole number times a fraction. So it's 9 sets of 1/2. Of is the most important word we can remember when multiplying fractions, right? Up above it was 3/4 of 20. This is 9 sets of 1/2. Okay? So just like we emphasized that of when we were doing whole number multiplication in earlier grades, 3 times 4 means 3 groups of 4, right? Or 3 rows of 4, or 3 jumps of 4. So with fractions, we're going to use that same of notion. Okay, 9/10 of the grade 8 class is in the gym. If these students are divided into 3 equal groups, what fraction of the whole class will be in each group? So how did you do this one?
10 students.
You drew 10 students?
That's just like box.
Okay.
Your people are using.
My people are too big. Okay, and then there's one poor little kid all by himself who's not there, so I'm going to make them in a different color.
He's in the classroom.
He's in the classroom. I don't know. Sick or something, maybe in the office. So 9/10 of the class are in the gym, and they're divided into 3 equal groups. So how much is in each group? 3 out of 10. Good. How do I write this symbolically? What is the number sentence I would write to describe this? 9/10 divided by 3. What's another way I could describe it?
In a number sentence or just how you would say it?
Yes, Craig.
Well, I drew like 10 blocks and then shaded in 9 of them,
Mm-hmm.
and then cut those into thirds. And then I ended up with 9/30, which just reduces down to 3/10.
Okay. Yeah, that works too. So we're doing an area model.
Yeah.
Mm-hmm. Except that's not division. Do you understand what Craig said he did?
What's that? What's that mean?
He did this. He did 9/10, so he sliced this 10 ways. 4, 5, 6, 7, 8. 9/10. So he shaved them. And then he cut them into thirds. And he took 1/3 of the 9/10 and got 3/10, 9/30, 3/10. Except, what is the appropriate expression for that?
One-third of.
Craig took 1/3 of 9/10. Is it appropriate when we are dividing something into 3 equal groups to also say we are taking 1/3 of it and putting it in each group?
Yes. Yes.
Right? If I was giving out snack, let's use a context we're all familiar with, and I was putting I was sharing it amongst 3 tables, is it fair to say that I could take 1/3 of the snack and put it on each table?
Yes.
Yes.
Because
Right.
that's what you end up doing with the rule later, right?
That's what you end up doing with the rule later. So when we're talking about division of whole numbers, it actually kind of jumps out that taking 1/3 of something or dividing something by 3 are the same thing. If I take half of something, I'm dividing it into 2 equal groups. Okay? So we can start to see the connection between multiplication and division of fractions, knowing that when I divide something by a whole number, I can take one, whatever it is, of that whole number, right? So if I had to share something in 4 equal groups, I could take 1/4 of that quantity and put it in each group. So we can have conversations about that around whole numbers. Now the question is, does that work when I'm dividing by a fraction? And how do I figure out what that other fraction is? Yeah?
Can you do the area model again? Yeah, color it, shade it.
Okay. Let me just start a new page because it wasn't a very pretty one. So if I take, and I'm going to break this into 10 parts. Okay, so that's 10 parts.
Okay.
I'm going to grab a highlighter. We're going to shade 9/10 of it. Good with that?
Yeah.
Okay, so I'm going to take 1/3 of the 9/10. Are you impressed with the highlighter, Dennis?
You hear what we said though?
No, I did not.
He said it was the highlight of his day.
Okay, so this whole space was the 9/10. Okay? 1/3 of it is this much, which is 9 shaded pieces out of how many pieces now? 30. 9 pieces are shaded out of a total possible 30 pieces. Because I broke each row, or I broke each column into 3 parts. So now I have 30 pieces instead of 10. So 1/3 of 9/10. Okay, and you can think of this as a height of 1/3 by a width of 1/10. Gives you an area of 9 out of 30. On your tables, you have a bunch of little sheets of paper. Like this. Everybody pick one up. I'm going to multiply 1/2 by 1/3 using this. Okay? So right now, we're going to assume that the length and width of this thing are 1 by 1. This is a unit square, so it's 1 unit by 1 unit. If I want to show a square that has, or a rectangle that has a height of 1/2, how can I show that? What would I have to do to this? Fold it in half. Let's do that. Okay, so I've folded it in half. So the area of the shape I have now in my hand is 1/2, the area of the original, so it's 1/2. It represents 1/2. And it's 1/2 high by 1 wide. Nope, it's 1/2 high by 1 wide so far. But we don't want it to be 1 wide, we want it to be 1/3. Third wide. So let's try and fold this little sucker into threes. It's okay if you're not perfectly exact. Okay, so now the piece that you're looking at is 1/2 by 1/3, right? Take your pencil and shade it. Shade the piece you're looking at.
Shade the one on.
Yeah. You folded it so your height is 1/2, your width is 1/3. Shade that whole thing. Okay? And now unfold it. Crazy town. Let's think about why this is 1/6. How many ways did I break it when I cut it in half? How many pieces did I break it into? Two. And how many pieces did I break it into when I cut it in thirds this way? Three. And what's the total number of little squares I have now?
6.
Because 2 times 3 is 6. Where do I see that? 2 times 3 gives me 6. And the 2 is right here, right? I broke it into 2 pieces of 1/2 height, right? And the 3 is here because I broke it into 3 1/3 pieces. And so now I have 6 little pieces, of which I shaded 1 by 1, which gives me 1 over, what did I do? Undo. Undo. My model disappeared. There it is. Okay, take another piece of paper. You still have more paper? Because I have more up here. I'm going to give you a hard one. Okay? Because you're my gifted class. How do you do 2/3? Doesn't matter which one you do first. Nope. You can do the quarters. Why does it not matter which one you do first? That was bad of me. Why does it not matter which one you do first? Because multiplication is commutative. I knew that's exactly what you were going to say. Right? Order doesn't matter. Multiplication is commutative. The thing that's a little different for this one is after you fold it in thirds, you need to kind of unfold it and flip one piece over so you have the 2/3 width, right? I fold it in thirds, but remember I need to have my width 2/3, so I'm going to do that.
And then we fold the 2/3.
And then you're going to fold that into doesn't matter. Doesn't matter which way you do it. Yeah. As long as you remember that it's 2 wide at the end. Did you get it? So then you can color in 2. Now the problem with this one, when you unfold it, is you don't get the least common or the lowest terms, but that's okay. The other way. When I'm doing quarters, I always like to do half and then half of the half. Makes me happy. So we'll grab the highlighter, and the part we have shaded is right here. we left with then? 2 out of 12. And where does the 2 come from? Where does the 2 come from? 2 by? So it's 2 out of 3. So the 2 is right here by the 1, which comes from the equation 2 times. And where does the 12 come from? 3 times 4. So we get 2 out of 12. But every good mathematician knows that you can't leave it like that, because it can be changed into a fraction with simpler numbers. And what would those numbers be? 1/6. Because we can divide both 2 and 12 by 2, or because we see them right here. Here's 1, right? Every group of 2 12ths becomes 1/6, and you can actually cluster them and see that. Okay? This is a nice way to use the area model. Okay? It's a nice way to get kids using the area models. I have also put on your tables some little transparent squares with lines on them. So open those up for a moment. One of them, that's because it's 1. So in your set, you should have a unit square, a half, thirds, quarters, okay? All the way up. We don't have 11ths, but we do have 12ths. So it goes to 10ths, it skips 11ths, because really, how often do you have to multiply by 11ths? And there are 12ths there. Although you likely won't use that one in the beginning we do. Okay, so let's look at some of these multiplication questions then. We haven't done question 2 yet, so we're going to come back to that in a minute when we do division. Let's think about 1/3 times 1/4. Let's look at this one. Okay? I want you to find thirds in your little transparent sheet. Okay? And then I want you to find quarters. Okay? I want you to imagine shading 1/3. We don't have any dry erase markers. It's cool if you do. But I want you to imagine shading 1/3 on one and 1/4 on the other. Okay? So you're going to have a square that has 1/3 shaded. I think I have these in here. So here's my thirds. Okay, I'm going to take my highlighter. And I need to find some quarters. I don't know how quarters. We're not at quarters here somewhere. So. to draw another square that's the same size. Okay, I'm just going to grab it, pull it over here. And we are going to break this up into quarters. You already have this one made, so give me a second while I make mine. Okay, and again, I'm going to take my little highlighter. I'm going to use this one in green. I'm going to shade a quarter. Watch this, Dennis. So now here's what we're going to do with this. We're going to take this and we're going to go like this. So you're going to rotate one. Yes, it is. And you're going to slide it over top of the other one. Okay, so 1/3 times 1/4 is 1/12, and it is the double shaded region, right? It's the area here that has been shaded twice. There is a great book that a lot of grade 8 teachers have called Actions with Fractions. And it has lots of great area model activities in it, and you get a little set of transparent blocks that you can photocopy onto overhead transparencies and give them to the kids, and they can use them to do their calculations. Okay? So the area model is our friend, isn't it? Yeah. Why can't you do it with those? Because they're strips and...
Shouldn't I be able to, like, overlap?
No, because it's about length and width, and the only thing they have that's different is the length. They don't have the width different. So, but you can do multiplication with those. It's a little harder to do. One of the things that we need to remember is the whole notion of the word of. So if I'm using strips, I think I have those here. So if, for example, I wanted to do a calculation like 1/2 of 2/3. Whoops. Okay, so 1/2 of 2/3. Modeling with these strips, I build 2/3 and I take half of it, which is what? 1/3, right? Half of 2/3 is just 1/3. So with these strips, you can model this as well, but it's not going to work for all of them. Okay, the area model will work always. These will work sometimes. If I wanted, let's try another one. Let's say 2/3 of 3/4. Okay, so I want 2/3 of 3/4. So I need to build 3/4 first, and this one is going to work nicely. So there's my 3/4. What is 2/3 of that? 2/4, right? Or, what's another way to express 2/4? With 1/2. Good. I think this is a half. Right? So 2/3 of 3/4 is 1/2. Okay, so these will work as well. But let's try 1/3 of 2/5. Okay? So if I built 2/5 and I wanted to take 1/3 of that, this is where it starts to kind of become more complex, right? So I've got to take my 2/5, break it into 3 equal groups, and take one of those 3 equal groups. So the way I might do that is by breaking each of the fifths, breaking each of the fifths into 3 parts.
If you know that the kids understand like the basic ones, when they start to get more complex, are they allowed just to multiply and numerator?
Absolutely. By the time we do multiplication, we're in grade 8.
They understand.
So we want them to model to get to the rules. And then we want them to internalize those models so they remember the rules. Right? But we do want to ask them questions like, with this model, how would I show 2/3 of that? And so what I've done with this one is I've broken each of the fifths into 3 equal pieces. So what size would those pieces be? 15ths, right? Why would they be 15ths? Right, and if I put all 5 of these together, I'd have 3, 6, 9, 12, 15, right? So each one of these little pieces is 15ths. Now if I were to take 2/3 of that, what's my answer? Here's 2/3 of it, right? Which is how many 15ths? 4 15ths. So you can still model with these, but it's not really as pretty as the area model. Once kids learn the area model, they will rarely do anything else because it just works, right? The only place where it starts to break down is when you get into whole numbers. So when you get into whole numbers, you need to be doing something else, right? So you need to be understanding the reasoning. And what I mean by that is if I have to multiply 2.5 by 1/4, right? What does my area model look like that's 2.5? You can still draw the area model that's 2.5 by 1/4, right? It would be a long, okay, so I'd have 2.5. My 1/4 is very fat. Let's make it more like this. We can erase the rest. Okay, so I'd have a whole set of 1/4, a whole set of 1/4, and half of 1/4. Does that make sense? We can dot in the... Okay? So I can imagine having quarters. Yep.
If you did the one that's number 2 where it's like written and you drew it like realistically, what is that called?
It's a strip model probably, or a length model. It's a linear model, yeah. Because if you actually drew out the length, yeah, and broke it into pieces, that's a linear model. Yeah.
Lisa, how do you explain? I just have an issue with the of. You're like, when do you explain why you say of?
Because that's what multiplication means. Multiplication.
To me, that sounds like division.
Well, multiplication means 3 groups of 4, 7 sets of 4.
Did you say 1/3 of?
1/3 of 1/4 feels like division because you're taking a part of something, but the operation that you're using is multiplication. And it's the same like what we talked about before. If I take 1/3 of something, it's the same as dividing it into 3. Right? So 1/3 of 20 is the very same thing as 20 divided by 3. And that's the thing that lets us do that reciprocal nature with division. But multiplication is of. That's the symbol that we use when we use the word of. Because when I divide, I often use by or into. Right? I break something into equal groups, or I share it in equal pieces, or I divide it by 6. Right? But you're thinking division because you're taking a part of, and that's a good thing because now you're thinking proportionally and you're thinking fraction, multiplicatively about fractions. So that's actually a good thing. let's go back up to question 2 that we skipped because we're going to talk a little bit about division before we run out of time. Okay. We have a big long strip of ribbon. In fact, it's 5.5 meters long, so I'm going to draw it. There it is. That's my piece of ribbon. It's 5.5 meters long. I might change that into a number line. That's a good idea, Kelly. Okay, so there's my 5.5. Bad half, but it's 5.5. How long do my little pieces need to be? 2/3 of a meter. So wouldn't it be nice if I broke this into thirds? It sounds like it might be a way to approach it. Okay, uh-oh. I only have half. Where does the third go on here? It actually goes about 2/3 of the way, doesn't it? Yeah, so it's more like about here, right? Okay, that little piece is going to be really important to me in a minute. It's probably about a 1/6. In fact, it's probably exactly a 1/6. So, what I'm doing right now is I'm going to start cutting. I'm going to take my imaginary scissors. I'm going to start slicing. I'm going to slice one piece right there, right? So that's 2/3 long. I'm going to do another one right there. Another one right there. Look, I've already cut 3 pieces. I'm going to cut another one right there. Another one right there. Another one right there. Because these are all 2/3 of a meter long, right? Keep going. Another one right there. Get another one right there. How many pieces I got? 8. Got 8 of them all together. And I got this little tiny bit left. What length of meter is left?
It's a half of a third, right?
It's not a half of a third.
It's a third of a half.
It's a 1/6, right, of a meter long. But my length that I'm looking for, my project strips, are actually 2/3 of a meter long. So my 1/6 is what piece of a 2/3?
Why didn't you do it like a 2/3?
Hmm?
Why didn't you do it like a 2/3?
Because every kid needs 2/3 of a meter. So this becomes my project, right? So what portion of my project strip do I need, or do I have? Yeah, like I have 1 out of the 4 equal pieces I would need to make another project, right? So I actually have 1/4 left over, even though the length of it is 1/6. And the reason it's 1/4 is because 1/6 is 1/4 of 2/3. Another way to think of this is imagine you are filling up measuring cups with like sugar or something. Okay? If I'm filling measuring cups up with sugar and I have this magic measuring cup that is exactly 2/3 of a cup, right? Because I don't like to have to fill up my 1/3 twice when I'm baking. I don't actually bake. That's kind of a joke. So this is 2/3 of a cup, okay? So what I'm saying is if I had that 1/6 of a cup of sugar, how much full would it make this 2/3? It would fill it a quarter of the way, okay? So 1/6 actually ends up being about a quarter of the 2/3. And you can look at your strips. The strips do a nice model of this. Here's 2/3. Here's 1/6. And I see right away that I would need 4 of the 1/6 to make another project that's 2/3 of a meter long. Okay. Division modeling is very hard for kids because they have to shift their thinking about what the whole is. Because now we're having a set. We're trying to make sets of a certain length that is a fraction, and it is the whole set. So it confuses people. Okay? It can be very confusing to figure out why it is that a 1/6 all of a sudden becomes a quarter. Right? And it's because the whole set now is 2/3 of a meter. And a 1/6 is 1/4 of 2/3 of a meter. Although my question was badly worded because I didn't say what fraction of a set do you have left. I actually said how much do you have left, which is technically you could say I had 1/6 of a meter left and I would still have to say, yeah, that's right. Okay? But we're going to talk a little bit about dividing here. Oops. So we already talked about dividing a fraction by a whole number and how it makes sense to multiply by the reciprocal, right? We know that when I divide a fraction by a whole number, if I divide something by 3, it means I'm breaking it into 3 equal groups, or I'm taking 1/3 of that thing, and that makes sense, right? Dividing by a whole number. But what about when we take a whole number and divide it by a fraction? So if I have 3, and I'm dividing it by 1/4. How might I conceptualize that? What model might I make? Yeah.
I was thinking that we talked about when like Craig did his model, but it was the same as we do the same as timesing it by 4. Dividing by 1/4 is the same as timesing it by 4.
Yeah, except his model was taking a fraction and breaking it into 3 equal groups. So now we're taking a whole number and breaking it into fractional groups. So the question we're asking is does that work the same way? Because unlike multiplication, division is not commutative, so we need to kind of convince ourselves that this works. Okay? How might I model this? Yeah?
You might try 3 squares and then divide each into 4.
I might draw 3 squares. And divide them each into 4 equal parts. And I might say to myself, how many sets of 1/4 are in 3? I might say to myself, how many quarters are in $3? And how many quarters are in 3? 12, right? So if I take a whole number and I divide it into small pieces, so I have 3 wholes, I'm cutting them into 1/4 pieces, right? We're fair sharing. It might be like 3 brownies and everybody gets a quarter of a brownie, right? Which really kind of sucks, unless they're really big brownies. And so how many people can we feed? 12 people. Will that model work for 6 divided by 1/5?
Yes.
So what's the answer already without even thinking about it? 30. How do you know? Because every whole would have how many fifths? 5. And how many of the wholes do we have? 6. So 6 sets of 5/5 is 30. We'd have 30 altogether. So then is it okay to say that dividing by fractions we could multiply by the whole number, right? So if it's 1/4, we can just multiply by 4. If it's 1/5, we can just multiply by 5, right? But what happened if it was 2/3? just change that real quick. Because you're gifted. I'm taking 5 and making sets of 2/3.
Would it be half? You don't want to end up with a whole number.
Nope, you don't. So let's first take 5 and break it into sets of 1/3. Would it be safe to say that if I was taking 5 and breaking it into sets of 1/3 that I'd have 15, right? But it's also safe to say that I could write 5 as 15/3. Yes? Divided by 2/3. Right? 15/3 divided by 2/3. This is the exact same expression, right? Because 5 can be written as 15/3. Now I'm going to cluster it into groups of 2/3. So I have 15/3, and I'm dividing it into groups of 2/3. So really all I'm doing is dividing 15 by 2. Right? Because the denominators are common, they no longer become significant. It could be dogs, it could be cats. I'm taking 15 of something and putting them in groups of 2 of that thing. No, we divide them into groups. If I have 15 cats. We're not cutting them in fractions. Okay, so how many do I have? 7.5. And I can see that. I can circle them. There's 1, 2, 3, 4, 5, 6, 7, and 1/3 left, but I need 2/3, so I have half of the set that I need.
What lost you there at the end?
It's the same thing that we did for last year.
How come when you multiply, you get exactly half that? No, you wouldn't.
No, you don't.
3.3.
Now I'm going to ask you, what could we have multiplied by instead? Instead of dividing by 2/3, what might you predict we could multiply by?
3/2.
3/2. Where does that come from?
Because there's 3 parts.
Where in my model did I multiply by 3?
When you divided your wholes into thirds.
Okay, when I divided my wholes into thirds, for every one I had, I broke it into 3 equal parts. Yep. So I took 15, or I got 15 by taking 5, breaking it into 3 equal parts. So 5 sets of 3/3 is 15/3. So that's where I got my timesing by 3, right? Where did I divide by 2?
When you put
When I took my 15 and broke it into groups of 2. So when I write this expression, 5 divided by 2/3, divided by 2/3, when I write it as 5 times 3/2, what I'm saying is multiply by 3 and then divide by 2. That line in the fraction means divide by, right? It's another way of saying divide by. So I can see I multiplied by 3, and then I divided it by 2 by clustering it into groups of 2/3, right? I multiplied by 3 by knowing that in every whole there are 3/3. And I divided by 2 by clustering those thirds into groups of 2.
But in this case, a whole is 2/3.
Yes. So I've made sets of 2/3. and I've made 7.5 of them. You good with that? Sweet. So now we're gonna like just stretch our brain. If I have 5/6, how many sets of 1/2 can I make? I'm gonna draw a new picture for this, okay? I'm gonna go to a big page because I want to draw a big picture. Okay, here's 5/6. You good with that? What would a half look like? How could I make a set of a half? 3/6 makes a half, right? So I could kind of, nope, not double shading, because that's multiplication. But I'm clustering into groups of a half. So here's a group of a half, right? So I have one group of a half. And I have part of another group of a half. What part of another group of a half do I have? 2/3. So I have 1 and 2/3. So 5/6 divided by 1/2, I can make one whole set and 2/3 of another set. Right, here's one whole set of a half, and here's 2 out of the 3 equal pieces I'd need to make another set of a half, right? Here's another way to think about this, though. What if I made my half this way? If I think about this set of a half, what fraction of a half do I have? If I'm just looking at the bottom one, what fraction of a half do I have? How many pieces? 5/6. If I look at the top half, what fraction of a half do I have? 5/6. Would it be safe to say that I have 5/6 of a half twice? Yep. So 5/6 of a half and 5/6 of a half. So I have 2 sets of 5/6 of a half, which gives me how many sixths of a half? Gives me 10/6, which reduces to it gives me 10/6, which reduces to 1 and 4/6, right? I could take this one, fill it in up there. 1 and 4/6, which reduces to 1 and 2/3. Get the same answer either way. Right? But this way shows you that I have 5/6 of a half, 5/6 of a half, so I have it twice, which is another way to show why that flip and multiply works. I took a set of a half. I have 5 out of the 6 equal pieces I would need, right? Jess? I have a set of a half. If this was all shaded in, this bottom part, I split it in 2, right? So if this was all shaded in, that would be a half, but I don't have a whole half. I only have 5 out of the 6 pieces I need. But on the top, I have 5 out of the 6 pieces I need to make another set of a half. So I have 10/6 of a half, which I can then reorganize. That's really what I have. I have 10 pieces of the 6 equal pieces I would need to make a set of a half. So I'd have 10, I'd have 1 whole set and 4/6 of another set. Yeah. Becky just said, are you asking yourself, how many whole halves do I have? That's exactly what we're saying. How many sets of a half can I make? Whole, right? How many whole sets of a half can I make? And in this case, I can make 5 6 of a half twice. Okay? If that model doesn't work for you, go back to this one where I had a whole set of a half and 2/3 of another set, which coincidentally is also 4/6 of another set, right? Okay, so tonight you can go home and model some more division. It'll be very, very exciting for you.